Hi, I'm Joel Weeman, and I'll be doing a presentation on nuclear medicine. And this will be kind of going over the history, the people who kind of helped uh, advance this, and just a bunch of facts. So, what exactly is nuclear medicine? It is the use of small radioactive materials that are put into the bloodstream. This can be through oral, like consumption, or an injection, and they give off gamma rays to detect defects in the body. And this uses imaging techniques to detect diseases in the earliest stages. So, a lot of this started off with the invention of the cyclotron, and this is invented by Ernest Orlando Lawrence. Basically, what the cyclotron is a little bit of like an apparatus type thing that uses atomic or subatomic particles, and they're accelerated kind of in a forward motion outward through an electric field to go through a magnetic field. Um, yeah, Lawrence started working at the University of California, Berkeley in 1928, and he was a nuclear physicist, and then kind of went more towards the chemistry side. And he also earned a Nobel Prize in 1939. So, how do you use chemistry? So, he proposed an intravenous or intramuscular injection of sodium chloride around the location of a tumor to attack that said tumor. In 1935, he went to Berkeley to research and studied leukemic ice with radioactive phosphorus. Also that year, he carried out his first biological experiments with neutrons and found out that they are 5 times more harmful than X-rays, which may come as a bit of a surprise to some people. But again, they've found ways to make it safe. And he retired in the 1970s and was given the Fermi Award in 1983 for his advancement and leadership towards the success in nuclear medicine. So he was one of the big influences that kind of helped move forward and propel, like especially with imaging. And another one that was really influential and kind of pushing it forward was George von Hevesy. He conceived the radio tracer techniques, and which could be used for to view the behavior of stable atoms, just kind of going over the atomic particles. And he also performed tracer studies by getting stable nuclides, and received. He also received a Nobel Prize in 1944. So obviously, we can see that both of these people were very important because they ended up receiving prizes. Both of these actually came from the Nobel Prize website, um, showing that like both of them, when you receive a Nobel Prize, it's a very high reward, and it means that you were able to give a good influence for like your area of study or your area of like influence. So these guys really like pushed um, pushed for success. So the advancement, we have come a long way in nuclear medicine. Imaging is probably one of the more safer procedures and it's one of the most common. TC99 specific is the most used ion for nuclear medicine procedure. Um, so these are all the other ones. We have technetium-99, we have fluorine-18, gallium-67, krypton-81, rubidium-82, nitrogen-13, indium-111, xenon-133, and thallium-201. Obviously, it's kind of a lot to keep track of, but the one we kind of like mainly focus on because it's so important is technetium-99 because it's helped around 40 million with around 40 million procedures per year, which means it accounts for 80% of all nuclear medicine procedures and 85% of diagnostic procedures. And this is all according to the Radiological Society of North America, RSNA. Some different procedures that use like all these things. So we have radium immunotherapy, which uses iodine 133, which is obviously listed in the slide before, to tag antibodies that target a specific cancerous cell. We also have thyroid ablation, which uses sodium iodide, which contains iodine 131, and the brachytherapy, which uses iridium 192, which is inserted near a cancer cell to kill it while sparing other cells close to it, which basically kind of says that it's a little more efficient or does like a little bit of a better job than chemotherapy. So the CDC also says that like abscess infection uses GA67 and indium 111 oxyquinoline, and for biliary tract blockage, they use 3 different types of TC99. We have desophenin, lidophinin, and mibraphenin. Desophenin and mibraphenin kind of do the exact same thing. They kind of look at the liver, gallbladder, and bile duct, and they kind of like help out and to make for better healing. And the lidophilins are mainly used for imaging and not exactly like overall pharmaceuticals, but it's still, it helps the disulfina and the mibrafina to do their job. Then blood volume studies, they use sodium chromate and CR51 just to kind of like look at the blood. So basic overview, nuclear medicine started off very experimental and very risky. But obviously you had some people like Ernest Lawrence who were very, very influential and very important for the overall study and really pushed boundaries and really tried to get it all advanced. And that made it way more safer for it to be used now, for doctors to be able to help people get treated as quick as possible. It allows for quick imaging and better surgical process. And early detection. It allows for early detection of diseases and other medical issues, just as efficient as it's as efficient as possible. And then radioactive drugs help this process. So obviously, I listed some of those earlier, and especially with like TC99, you have certain ones that are mainly used to help heal certain areas, and then you have some of them that also like help with the imaging process to view if it can be helped in the efficiently or not. And so here's now we're excited, and thank you.